Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about how black holes are shrinking in mass and size. This is called Hawking radiation, and as you can guess, this was something that was thought of by Stephen Hawking. So the idea goes that if you take empty space and you take everything out of it, so you suck all the air out, there are no atoms, nothing in there, totally empty seemingly, and you zoom into really small scales, on truly quantum scales, on subatomic particle scales, then what we find is that empty space is actually not empty. What we find is it's kind of bubbling with virtual particles. So space all around us, vacuum all around in the universe, between planets and galaxies, everywhere, in this room that I'm in this room you are in, everywhere. Space on fundamental small scales is actually bubbling with virtual particles, and what these virtual particles are a positive and a negative particle that kind of pop into existence. They exist for a very small amount of time and they almost immediately collide back together and annihilate each other. So this is allowed to happen because the net sum of this kind of interaction is zero in terms of energy. So you get a positive energy, negative energy particle, and they absolutely cancel each other out. And this happens all the time everywhere at really small scales. And so what Stephen Hawking's thought was that if you take the black hole, so around it we have this event horizon, this point of no return, and if we apply the same logic, so the vacuum is full of these virtual particles, so the idea is that near this event horizon, the point of no return from which no particle can escape, in the border of this event horizon, particles are also popping in and out of existence. And so the idea being that two particles pop into existence, these virtual particles, one of them falls into the black hole and another one escapes the black hole. And the one that falls into the black hole is always a negative particle, and the other particle that escapes, this becomes a real particle, like I'm a real particle now, and escapes the black hole. And the negative particle, this subtracts from the mass of the actual black hole. Now, this is something that is a really slow process, but it's proven that black holes do lose mass in this way. This takes enormous amount of time, trillions and trillions of years. Like, black holes will be the things alive longest in our universe. They will be the last things to disappear from existence. But even black holes have an end. I was kind of sad to learn that because these were always such, magical objects. So immense and powerful, and seeing that they also die and age in a way is kind of, I don't know, sad in a way, kind of a bummer. But yeah, it's interesting. So black holes do lose mass really slowly over time because of these virtual particles essentially stealing mass from it in a weird way. So I also have a video about black holes if you're in any way interested, and yeah, this is about the Hawking radiation. So hope you got something interesting from this video, and thank you so much for watching, and take care.